What is a hyperbola, and how is it related to the first three conic sections? A hyperbola is the set of all points on a plane such that the difference of the distances of each point from two fixed points is constant. So all hyperbolas have two branches, each with vertex and focus, as you can see in the illustration. And also, as you can see, it looks like two parabolas, but its properties and parts are just like ellipse. So here are the parts of a hyperbola. As you can see in our illustration, a hyperbola has so many parts. Let's start with the center. The center is the midpoint of the line segment joining its foci. Again, for our hyperbola, just like an ellipse, we have two foci. And the center, again, is the midpoint of the line segment joining its foci. The second one, we have the foci. Again, it is denoted by f sub 1 and f sub 2. Again, it is a special point with reference to which any of a variety of curves is constructed. The next part, we have the transverse axis. Now, if in ellipse we have the major axis, in hyperbola we have the transverse axis. It is the line segment that contains the center and foci, and whose endpoints are the two vertices of the hyperbola. For the next one, we have the conjugate axis. Now, it is the counterpart of the minor axis of an ellipse. The conjugate axis is the straight line through the center which is perpendicular to the transverse axis and does not meet the hyperbola in real points. In hyperbolas, we also have vertices. It is the endpoints, or they are the endpoints of the transverse axis, and they are denoted by v sub 1 and v sub 2, just like the endpoints of the major axis of an ellipse. We also have the co-vertices, which are the endpoints of the conjugate axis. Again, they are denoted by v prime sub 1 and v prime sub 2. The next one is the semi-transverse axis. Now, its counterpart in ellipse is the semi-major axis. Again, it is the distance from the center to the vertex, and it is denoted by A. We also have the semi-conjugate axis. Its counterpart in ellipse is the semi-minor axis. It is the distance from the center to the co-vertex, which is denoted by B. And the next one, we also have the focal length. It is the distance from the center to the focus, and it is denoted by C. So in hyperbolas, we also have the latus rectum. The chord, again, of the hyperbola through its one focus, perpendicular to the transverse axis, and is parallel to the conjugate axis. Now, the latus rectum of a hyperbola is just like the latus rectum of an ellipse. We can get it by getting 2b squared all over a. In a hyperbola, we also have asymptotes, which are the lines that are not part of the hyperbola but show where the curve would go if continued indefinitely in each of the four directions. Now, asymptotes are the lines that will never intersect our hyperbola. So those are the parts of hyperbola. If the major axis of an ellipse can either be horizontal or vertical, It is also the same with the transverse axis of the hyperbola. It can also be horizontal or vertical, as you can see in the illustration. So the hyperbola can either open upward and downward, or to the left or to the right. Now, the equations of hyperbola are almost identical to the equations of ellipse. Again, in ellipse, the sum of distances of any points from the two foci is constant. Again, the sum. And according to the definition of hyperbola, the constant value is the difference of the distances. But, just like an ellipse, the equation depends on the orientation of the hyperbola. When the transverse axis is horizontal, the equation of the hyperbola in standard form is x minus h squared all over a squared minus y minus k squared all over b squared is equal to 1. And if the transverse axis is vertical, the equation of the hyperbola in standard form is quantity y minus k squared all over a squared minus quantity x minus h squared all over b squared is equal to 1. Where again h is the x-coordinate of the center, k is the y-coordinate of the center, a is the semi-transverse axis, and b is the semi-conjugate axis. Now as you can see, if x is squared is positive and y squared is negative, the orientation is horizontal. On the other hand, if y squared is positive, then it is vertical. And again, a squared is always under the positive term. So those are the equations in standard form of hyperbola. Now let's have example number 1. We have to write the equation of a hyperbola in general form, which is centered at the origin or 0, 0, a focus at positive 5, 0, and a vertex at positive 3, 0. Then we have to sketch the graph of our hyperbola. Now since our center, a focus, and a vertex are already given, we can plot the points for these parts. Again, the center is at the origin, which is 0, 0, and we have a focus at 5, 0, and the vertex at 3, 0. Now, by just looking at our three given points, we can assume that another vertex is at negative 3, 0. And the other focus is at negative 5, 0. So, by just looking at the points that are given so far, we can conclude that our hyperbola or the transverse axis of our hyperbola is horizontal. Therefore, we're going to use x minus h squared all over a squared minus quantity y minus k squared all over b squared is equal to 1. Now, by looking at the points, we can clearly see the value of A, or our semi-transverse axis. Again, it is the distance from the center up to one vertex. Therefore, A is equal to 3. Again, we can also see C, or the focal length. Again, the distance from the center up to the focus, which is 5. So C is equal to 5. But we still don't have the points for our conjugate or the co-vertices. Therefore, we don't have the value for B yet. Now, how can we find the value of B given the values of A and C? Now, in hyperbolas, we can also apply the Pythagorean theorem. But unlike in an ellipse, A is the longest segment. But, as you can see, in a hyperbola, the longest segment is c, or the focal length. Therefore, we're going to use c squared is equal to a squared plus b squared, the Pythagorean theorem itself. So to solve for b, we have 5 squared is equal to 3 squared plus b squared. That is 25 minus 9 is equal to b squared. That is the square root of 16 is equal to 4. Therefore, b is equal to 4. So if the semi-conjugate axis is equal to 4, we are going to count 4 units upward and downward our center. So there we have the endpoints or the co-vertices of our hyperbola. So just like what we did in parabola and ellipse, we have to find the latus rectum for us to determine how wide our curve will be. So again, to find the latus rectum, we will have 2b squared all over a. So we have 2 times 4 squared all over 3. That is equal to 32 over 3, or approximately equal to 10.67. Therefore, from the focus, we have to count 5.33 units to the right and to the left. So there are the endpoints of our latus rectum. Next, in order for us to sketch the graph of our hyperbola, we have to draw a rectangle that will pass through our vertices and the co-vertices. For what? To sketch our asymptotes. For us to determine where our hyperbola will approximately approach to. Now, how can we sketch our asymptotes using the rectangle that coincides the center of our hyperbola? The asymptotes of the hyperbola are straight lines that are the diagonals of this rectangle. So there are the asymptotes of our hyperbola. So by just looking at our asymptotes, we can already observe the orientation and the behavior of our graph. So let's just connect the endpoints of our latus rectum and the vertices. Again, as you can see, the hyperbola approaches our asymptotes. So here's the graph for this hyperbola. So now that we have graphed our hyperbola for this given, we can now write the equation. Given again our semi-transverse axis, semi-conjugate axis, and our focal length. Again, our semi-transverse axis or A is equal to 3, and our semi-conjugate axis or B is equal to 4. And again, as you can see, the center is at the origin. Therefore, H and K are 0, 0. So we have x squared and y squared. Again, A is 3, B is 4. So we have x squared all over 3 squared minus y squared all over 4 squared is equal to 1. Now, how can we write this in general form? Again, we have to get 3 squared and 4 squared. So we will have x squared all over 9 minus y squared all over 16 is equal to 1. Again, we have to write this in general form. So we have to multiply both sides by the LCD, which is 144. So to multiply, we have 144 times x squared over 9, that is 16x squared, minus 144 times y squared all over 16, that is negative 9y squared, is equal to 1 times 144, that is 144. And we have to transpose 144 to the other side of the equation, so we will have 16x squared minus 9y squared minus 144 is equal to 0. So that is the equation in general form of the hyperbola centered at 0, 0, a focus at 5, 0, and a vertex at 3, 0. For example 2, let's do it the other way around. Now, given the equation, we have to find the coordinates of the center, vertices, co-vertices, foci, the length of the semi-transverse axis, semi-conjugate axis, and the latus rectum of a hyperbola with an equation of 12y squared minus 4x squared plus 16x plus 72y plus 44 is equal to 0. Again, we have to transform this given equation in general form to its standard form for us to find the coordinates or the parts of our hyperbola. So how are we going to do that? Again, we're going to perform completing the square. So our first step again is to group all the terms with the same variable and transpose our constant term to the other side of the equation. So now we have 12y squared plus 72y minus 4x squared minus 16x is equal to negative 44. Now, as you can see, we have minus because we have a hyperbola. Then, negative 4x squared became positive 4x squared, and positive 16x became negative 16x because again, we have minus. For the next one, again, we have to get the factors out or the common factors. For the first two terms, we have the common factor is 12. So we will have 12 times y squared plus 6y. That is 72 divided by 12. And then let's do the same thing for our next terms. The common factor is positive 4. So we will have 4 times x squared minus 4x is equal to negative 44. Now that the numerical coefficients of x squared and y squared is just 1, we can now use completing the square. So again, to complete the square, we will have 12 times y squared plus 6y plus 9. Now, where did that come from? Again, to complete the square, we have to get half of our second term, which is 6y. So that is 3, or 6, that is 3. Then square it, that is 9. For the next one, we have x squared minus 4x. Half of negative 4 is negative 2. Negative 2 squared is positive 4. Therefore, we have negative 4 times x squared minus 4x plus 4 is equal to negative 44. Again, we have to add our constant terms. Therefore, we have negative 44 plus 12 times 9 is 108. Then we have negative 4 times positive 4 is negative 16. So we have negative 44 plus 108 minus 16. So now we can get the factors. We have 12 times y plus 3 squared minus 4 times x minus 2 squared is equal to negative 44 plus 108 minus 16 is equal to 48. Again, to transform this into its standard form, our constant term must be equal to 1. So we have to divide both sides by 48. So now we will have 12 divided by 48, that is 1 over 4. So we will have y plus 3 squared all over 4. Next, we have negative 4 divided by 48, that is negative 1 over 12. So we have minus quantity x minus 2 squared all over 12 is equal to 48 divided by 48 is equal to 1. So that is the standard form of this given equation. Now, as you can see, y squared is positive and x squared is negative. Therefore, we can conclude that the transverse axis of our hyperbola is vertical. So now that we have transformed our general form of equation into its standard form, we can now determine the parts of our hyperbola. Let's start with the center. So by just looking at the values of our h and k, we can conclude that the center of our hyperbola is at positive 2, negative 3. So let's plot the point for our center. Again, we have 2, negative 3. Now, again, we can also determine our A, or the semi-transverse axis. Again, A squared is under our positive terms, which is 4. So A squared is equal to 4. So if A squared is equal to 4, therefore A is equal to 2. So that is our semi-transverse axis. And again, our transverse axis is vertical. So we have to count 2 units upward and downward from our center. So the endpoints of our transverse axis, or our vertices, is at positive 2, negative 1, and our v sub 2 is at positive 2, negative 5. Again, those are our vertices. We can also determine b by getting b squared, which is equal to 12. So b is equal to the square root of 12, or approximately equal to 3.5. So if b, or our semi-conjugate axis, is 3.5, we have now to count 3.5 units to the right and to the left from our center. So v prime sub 1 is at 5.5, negative 3, and v prime sub 2 is at negative 1.5, negative 3. Next, we have to find our foci, or the coordinates of our foci. Now, since we still don't have c, or the focal length, we can now get c by using the Pythagorean theorem again. So we have c squared is equal to a squared, that is 2 squared, plus b squared, that is the square root of 12 squared. So c squared is equal to 2 squared is 4, plus the square root of 12 squared is equal to 12. So c squared is equal to 16, therefore c is equal to 4. Our focal length is 4. Again, to get the coordinates of the foci, we are going to count 4 units from the center. So, there we have our foci. F sub 1 is at positive 2, positive 1, and F sub 2 is at 2, negative 7. The next one, we can get our latus rectum by again using 2b squared all over a. So we will have 2 times 12, that is our b squared, all over 2. Therefore, our latus rectum is equal to 12. So if our latus rectum is equal to 12, we now have to count 6 units to the right and to the left of our focus. So there we have the endpoints of our latus rectum. Again, to the right and to the left of our focus, since our hyperbola is vertical. Again, to sketch our asymptotes, we have to draw a rectangle that will pass through our vertices and co-vertices. And again, the asymptotes will pass through the diagonals of our rectangle. So as you can see, we can now observe the behavior of our hyperbola. So we can now connect all the points, or the endpoints, of our latus rectum and the vertices. So there we have the graph for 12y squared minus 4x squared plus 16x plus 72y plus 44 is equal to 0.